if I want to find the equivalent resistance here, R equivalent, what I can do this is a bridge network, and what I can do is this is a delta here, I can transfer it into a Y, so Y delta transformation. So this is my node 1, node 2, node 3, so I will keep the nodes same, so here, then here, then here, and then at this point R4 and R5 is coming in. So basically this is R4, this is R5, and this is the new values. So this one will be essentially R1 R2 times over R1 plus R2 plus R3, just like before, as I showed in the last video. And yeah, so this is the resistance I need to find out. This resistance will be here, R2 R3 over R1 plus R2 plus R3, and this resistance here, because there is R1 and R3 here, R1 and R3 at node 2, and this is the node 2, so this is node 2, this is node 3, and this is node 1, and this is the neutral point. So this at node 2, R3 and R1 are connected, so R1 R3 over R1 plus R2 plus R3, this is the common denominator everywhere. So that's it, and then these two are in series. So this resistance, if I call it R whatever R2Y, and then this is R1Y, maybe this one, this is R2Y, and this is R3Y, if I just for the sake of simplicity. So R equivalent finally will be R2Y plus, so basically it will be R1Y, which is this resistance, plus R2Y, which is this resistance, in series with R4, which is this one, and these two, this one and this one, so R3Y and R5, these two are coming in series, and R3Y R5, this series is in parallel with this one, so this is R3Y plus R5, and these two resistances are in parallel with R2Y plus R4. So yeah, if we can just solve this, we will get, so basically the final result will be something like this. So sorry, this will be a plus here. So basically it's R2Y plus R11. Of course in a real system we will have values, so yeah, we will calculate the values in each cases in every steps, so it will be simplified, but anyway that's how we do it. And then it's just a parallel combination, so I'm not going into that. R4 plus R3Y plus R5, whatever, I'm not sure if I have written it correctly, yeah, because R1 parallel R2 is R1 R2 over R1 plus R2, so that's what it is I have written here. So yes, this is an equivalent resistance. Now one more equivalent resistance problem I want to do is here. So if I have something like this, and then this is a short circuit, these are very basic understanding of equivalent resistance. So yes, R1, R2, R3, R4, this is coming here, so I need to find R equivalent here. Now these two are the same point, that means the circuit is actually basically R1, I can write it like that, draw it like that, sorry, this looks better if I draw it like that. So this is R1, R2 which are in parallel, and R3, R4, and then this is where it's also important to observe where the resistance, from where I am resisting, looking at the resistances. So R1, R2 parallel, just one combination, so this is, and then in series with R1, R4. So R equivalent will be R1 parallel R2, and then series R3 parallel R4. this is R4, this is one more. So in this one, if we want to say what is the equivalent voltage at here, that is RCD, that is essentially R1 plus R3. These two R1 and R3 are coming in series, and then this whole thing is in parallel with R2 plus R4. So R2 and R4 are also series. So this is probably pretty obvious. Now another situation, if we say what is the resistance looking at RAB. So if there is a voltage source here, what will be the resistance? Again, that's probably pretty obvious that these two, the resistance will be, because these are C and D, here it's open, so we don't consider that. So it's becoming R1 plus R2. Those two are in series, because this is R2, this is R1, this is R3, this is R4. So R1 plus R2 coming in parallel with R3 plus R4. Now let's think of another situation. The same resistance. What's the resistance at RAB? But this one is short circuited. So we still want to find what is RAB. In this case, it's better we redraw the thing. So what we can do is A and B is here. And from A we have, so from A we have R2. So let's do R2 here, which is R2, it's going to C. And from A again we have R4, which is going to D. So we have R4, which is going to D. This is D. So this is A, this is B. Again from B we have R1 going to C. So R1 is going to C. And we have from B R3 going to D. R3 is going to D. So this is R3, this is R1. So from B we have R1 going to C here, and from B R3 going to D. And finally C and D are short circuited. So basically C and D are the same point. So what we have now is RAB will be resistance R2 is in parallel with R4, because R2, this one is parallel with this one, since A and say this point and this point are the both ends of the resistance are connected at the same point here. So one end of both the resistance are connected at the same point, and then the other end also connected at the same point. And then this one is coming in series with R1 parallel R3. So basically when we have something like that and it's looks pretty not very straightforward to find the equivalent resistance, it's better to redraw it, just point-wise redrawing. And if the points are not labeled, we can label the points so that it becomes easier to redraw. So that's how it becomes simpler that way, in my view.